Angles of elevation and depression. An angle of elevation is an angle formed by the horizon or horizontal line and the angle below the line of sight between the two objects. Basically, if you're looking up. The angle of depression is if you're looking down. Whenever we're looking out, we always have the horizon or a straight line coming out. If you're depressed, you're looking down. If you see someone depressed walking around school, then they're looking down at the ground watching their feet. If you see someone happy and elevated, then they're looking up. So the airplane guy, he's depressed, he has to land, so he's looking down, angle of depression, at the tower. The people in the tower are elevated, they're happy that it's almost time to go home, so they're looking up. Angle of depression, angle of elevation. If we have this very blurry picture here, we can go through the numbers. We have a bird who's looking down at the man, wondering why he's standing on his nest, which makes him very depressed. That's an angle of depression, the bird looking down at the man. We also have the man looking up at the bird. He's excited, he's seeing a bird he's never seen before, so that's angle of elevation. The man is then looking down at the tree. He's depressed because he only sees one tree. The tree is looking up at the man, and he is elevated and excited that he can actually see the man because he's a tree and trees shouldn't be able to see. So these are the ways of angle of elevation or depression. If you're looking straight out and you look up, you're elevated. If you're looking straight out and then look down, it's depression. Now for all of these, you're going to want to draw pictures. Specifically, you're going to want to draw a triangle. This is a boat detects an object at the bottom of the ocean floor 5 miles away. When looking down at an angle of 28 degrees, find the depth of the object. So here's my amazing picture. We have a boat with a little tiny sail on it, floating on the ocean. It detects an object down there, a little box, 5 miles away. So the hypotenuse of my triangle here is 5 miles. We know it's a right triangle because we only draw right triangles. And they told us that the angle of depression right here is 28 degrees. They want us to find the missing side x. This is where our trig comes in. So if you're not familiar with SOHCAHTOA and all the other trig, make sure you go back and review that. Looking here, I have the 28 degrees, I have a hypotenuse, and I have the side opposite. If I have an opposite and a hypotenuse, I'm going to use S for sine. Then solve for x. That leaves you with x is equal to 5 times sine of 28, at which point you simply plug it into your calculator. And that gives you x is equal to 2.3. So you'd say the object is 2.3 miles below the ocean surface. Next, it says a biologist whose eye level is 6 feet above the ground. That's important because that means we're going to have to add 6 to our answer. Measures the angle of elevation to the top of the tree to be 38.7 degrees. If the biologist is standing 180 feet from the tree's base, what is the height of the tree to the nearest foot? So here we have our biologist. We know that the biologist is 6 feet above the ground. So from the eyes to the floor is 6 feet. We also know that the biologist is looking up at an angle of 38.7 degrees. And we know that the biologist is 180 feet away from the tree. And they want to know how tall the tree is. Now granted, how tall the tree is from the top all the way to the bottom. What we're going to have to do is figure out how tall it is from the eyes to the top, that's our x, and then add the extra 6 feet. Again, we're going to use SOHCAHTOA. Here I have the adjacent, which is 180 degrees, and I need to find the opposite, which is x. So that means we're going to use tangent opposite over adjacent. Then solve for x, and plug it into your calculator. Now they told us to round to the nearest foot, so I have x is equal to 144 feet. That means from the eye level to the top is equal to 144. But if I want the entire thing, I'm going to have to add the 6. So the total height of the tree is 150 feet tall. Don't forget your units, which are in feet. For the next one, we have the flagpole in Terry's schoolyard is 42 feet tall. On a sunny day, the flagpole casts a shadow of 20 feet long. What is the angle of elevation? So now we're finding the angle of the sun at that moment, and they want us to round to the nearest tenth of a degree. As always, draw a picture. Now, they already know the height of the flagpole. The height of the flagpole is 42 feet tall. We can assume that the flagpole is straight up and down, so it's at a 90-degree angle. And the distance that we can measure on the ground is 20 feet. What they want us to find is the angle of elevation. Angle of elevation is looking down and going up. So that is our x. Again, we're going to use SOHCAHTOA. From my angle, I have the opposite and the adjacent. Tangent is opposite over adjacent, and that's what we'll use. Tangent of x is equal to 42 over 20. In order to get the x all by itself, you take the inverse. The inverse cancels out the tangent, and you're left with x is equal to tan inverse of 42 over 20. At this point, you plug it into your calculator, and you get 64.5. So the angle of elevation of the sun is 64.5. Last one here, we have Kurt leans a 20-foot long ladder against the side of the house. The ladder reaches to a height of 18.9 feet up the side of the house. What is the angle of elevation of the ladder to the nearest tenth of the degree? Draw your picture. Here we have a 20-foot ladder, so the orange ladder is leaned up against the house. It is up 18.9 feet tall on the house. We are assuming that our house is built correctly and has a right angle at the bottom, and they want us to find the angle of elevation, which means looking from the ground up, what is this angle down here? Angle x. Again, we use SOHCAHTOA. I have the opposite, which is 18.9, and the hypotenuse, which is the longest side across from the right angle. The opposite and the hypotenuse means I'm going to be using sine. Use the inverse to cancel out the sine and free the x, which gives you x is equal to sine inverse of 18.9 over 20. And when you plug that in your calculator, you get 70.9 because they said to the nearest tenth of a degree. Make sure you're always reading the instructions. So our angle of elevation is 70.9 degrees.